This is problem number 33 from your book in chapter 9. It's also web assigned 36 problem number 1. It has to do with the tension on a string of a balloon filled with helium. So an empty rubber balloon has a mass, as shown in the problem. It's filled with helium and it gives you the density. And it tells you that the balloon is spherical, which will help you determine the volume of air displaced and the mass of the helium. So they fasten it to a vertical line and they want to know the tension. The first thing you should do is draw a free body diagram. So if this is my balloon, I have the gravitational force pulling the balloon down. We'll call that the weight of the balloon. I also have tension pulling the balloon down and the buoyant force on the balloon. So since we know that the balloon is not accelerating up or down, I can say the net force on the balloon is 0. So that means the buoyant force on the balloon minus the weight of the balloon minus tension equals 0. I can then solve for tension. That would be equal to the buoyant force on the balloon minus the weight of the balloon. Okay, to find the weight of the balloon, you really have to take into account the mass of the deflated balloon, which is given to you in the problem, and the weight of helium. Well, they give you the density of helium, and they also give you a radius of the balloon when it is inflated, and they tell you it's spherical. So the mass of helium will be equal to the density of helium times the volume of helium. Well, the volume is the spherical volume. The volume of a sphere is 4/3 pi r cubed. And when I put in the radius, I get a volume for the balloon of 0.9048 cubic meters. So then I can find the mass of helium using the density, and I get 0.1638 kilograms. The weight of the balloon then is the mass of helium plus the mass of the deflated balloon times the acceleration due to gravity, and we find a weight of the inflated balloon equal to 1.7179 newtons. Now we'll also use this volume to determine the buoyant force because we need the volume of the fluid displaced, and the volume of the fluid is the volume of the balloon. Okay, so as we said before, we determine the volume of the balloon that will be equal to the volume of the air displaced. Now the buoyant force is equal to the weight of the air displaced. So we can find that easily. The weight is simply the density of air, which, by the way, you have to look up in your book. I'm not sure what page that's on, but that is in chapter 9 in your book. So the weight is the density times the volume of air displaced times the acceleration due to gravity. And we can find the weight of the air displaced. That's 11.44 newtons. Now we found the tension before from the free body diagram. We said it was equal to the buoyant force on the balloon, which we found in the previous slide, 11.44 newtons, minus the weight of the balloon, which we found 2 slides ago, and that gives you a tension of 9.72 newtons. Hope this was helpful.